Let's try to see the approach of this question. Prove the following. 21. How do we approach this question? In the LHS, you have pretty complicated expressions. Yes, you have angles 4x, 3x and 2x in the numerator. You have similar angles 4x, 3x and 2x again in the denominator. Okay. So the idea that I have in my mind is to simply use transformation formula, use any two angles and convert them into the product. Okay. So I have cos C plus cos D. I look at cos C plus cos D in the numerator. What is cos C plus cos D equal to? I'll combine any two angles, right? What is cos C plus cos D equal to? That is equal to 2 cos C plus D by 2 sin C minus D by 2. What about sin C plus sin D? Sin C plus sin D will be required in the denominator. This is equal to 2 sin C plus D by 2 cos C minus D by 2. Cos C plus cos D would have a cos over here, not a sin over here. This is cos C plus D by 2, right? Let's write the formula properly. That's not the correct formula. This is 2 cos C plus D by 2 cos of C minus D by 2. Sin C plus sin D is 2 sin C plus D by 2 cos of C minus D by 2. Once we have okay with this, let's begin with the LHS. What does the LHS say? LHS says that can we club together any two particular angles? Yeah. So let's take the two extremes and club them together. That's the easiest step, right? Let's club the two extremes. What you have is cos 4x plus cos 2x. Okay, and a cos 3x. What about the denominator? Similarly, we'll club together two extreme angles. Sin 4x, sin 2x will come together, and sin 3x will remain separate, right? Sin 4x plus sin 2x and sin 3x can be written separately, right? Remember, keep in mind that you have to reach this angle 3x finally. Okay, how do we reach that? Please observe. Cos C plus cos D, cos 4x plus cos 2x will be 2 cos 4x plus 2x, that is 6x by 2. Cos of 4x minus 2x by 2, which is cos of 2x by 2. So this is 2 cos 6x by 2 cos of 2x by 2 plus cos 3x is already there. What do you have in the denominator? You have sin 4x plus sin 2x. Sin C plus sin D is 2 sin C plus D by 2 cos of C minus D by 2. Sin 6x plus sin 2x will be equal to 2 sin 6x plus 2x 8x by 2. Sorry, 4x plus 2x 8x by 2. 2 sin 6x by 2. And along with that you have sin 4x, sorry, cos 4x minus 2x, which is cos of 2x by 2. Okay, these are the angles that you have over here, plus there's another term in the denominator which is sin 3x. Let it remain as it is. What does the numerator simplify into further? Please observe, in the numerator you have 2 cos 3x cos x now. Plus there is another cos 3x. Okay, what about the denominator? You have sin 3x and cos x again. Plus this is sin 3x. Okay, what else? Once you have solved this much, let's continue further. This implies LHS. Okay, let's keep this separate. LHS will be further equal to what? Can you observe that cos 3x and cos 3x are common in these terms, and let's take that out. Cos 3x will come out common in the numerator. What remains is 2 cos x from the first term. What about this term? If you take out cos 3x, what will remain? Nothing, basically 1, right? This is in product, right? So 1 will remain over here. Similarly, sin 3x can come out common over here. And this 2 cos x plus 1 remains over here. Okay, now I see an interesting thing. I can cancel these 2 cos x plus 1 and I get as cos x cos 3x over sin 3x. Cos 3x over sin 3x is equal to cot 3x. Is equal to cot 3x, and that is what was required. That is all for this question.